Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the questions in Paper 2 of the 2014 JEE Advanced Physics question paper. Let's start with question 1. A tennis ball is dropped on a horizontal smooth surface and it bounces back to its original position. So you have a horizontal smooth surface, you drop a tennis ball, it falls down with increasing speed, and then it suffers a change in speed here and it goes back and it comes back to zero speed here. The force on the ball during the collision is proportional to the length of the compression. Which figure describes the variation of kinetic energy with time? So if we look at the three options, we know that instantaneously here the speed does become zero. Right, it increases to a maximum value, but then once it's being compressed, there's a point where the speed becomes zero and then the velocity becomes in the opposite direction. So option C can immediately be ruled out. Option A, B and D, the only difference in them is the part from here to here, from going from initial point to the floor, right? And they all start with speed 0 or kinetic energy 0 and stop with kinetic energy 0. So that's the part which we need to worry about. And in this part, we know that the initial velocity is 0, so V will be equal to AT or GT, which means the kinetic energy, which is half mv squared, becomes half mg squared t squared, which is proportional to t squared. So it's a parabola, and we know a parabola goes like this. And the only option in which initially it starts out like this is option B. So that is the answer. Let's move on to question 2. We have a semicircular wire, and on one end we've kept an object, a bead, and it rolls down to the other end. And we are asked about the force that the bead applies on the wire. So this is the first source of error that some students might make. They might calculate the normal force on this bead and take that to be the answer. The normal force on this bead, whatever it will be the force applied by the wire on this bead. The force applied on the wire by this bead will be equal and opposite by Newton's third law, so you'll have to reverse the direction for the answer. So first we'll calculate the normal force, then we'll figure out the reaction force, which will just be the opposite of that. Now initially when you leave here, it's going to the right, but its acceleration is 0, right? Because its speed is 0. It starts with 0 speed, so v square by r in this direction is 0. That means mg is equal to n. So initially the normal force is radially outwards. By the time it reaches this point, it has some speed, so it actually has a component of force in this direction, which actually gives it mv squared by r, right? And obviously gravity is vertical, so this has to be the normal force. So even qualitatively, we can see that initially the normal force is radially outwards, at the end it is radially inwards, so it makes sense that there must be some point at which it changes its direction. And we see the options: always radially outwards, always radially inwards, or initially outwards, finally inwards, and vice versa. So it seems to us that it should be either C or D, because initially the normal is radially outwards and finally the normal is radially inwards. So let's just try to solve it rigorously at any random point theta. Let's assume this is the normal force radially outwards. It's either radially outwards or radially inwards because it has to be perpendicular to the surface. This is mg, this is theta. So the equation in the radial direction is mg cos theta minus n is equal to mv squared by r. Right, but another equation would be, if the speed is 0 here and here is v, we can conserve energy between these 2 points. So the work done by gravity, which will be mgr times 1 minus cos theta, because initially it is at a height r, then this is r cos theta, so what is left is r into 1 minus cos theta, is equal to half mv squared. So if you put this in this equation, you take 2 to the other side and you take r to this side, you get mv squared by r is 2mg into 1 minus cos theta. So mg cos theta minus n is equal to 2mg times 1 minus cos theta, which gives us n is equal to this is 2 mg and this is 3 mg cos theta. So 3 mg cos theta minus 2. Initially theta is 0, so it is mg. That means it is positive, so radially outwards. Finally theta is pi by 2. Right, this is minus 2 mg by the way. Finally theta is pi by 2, so this is 0, so this is minus 2 mg. That means radially inwards. Because we've assumed radially outwards, a negative normal force means radially inwards. So we get that the normal force is out. Actually we got this qualitatively as well, but I just wanted to show you that at cos theta is equal to 2 by 3, which is some angle in between 0 and 90, the normal force becomes 0 and then it changes direction. Right, that's not explicitly asked in the question, but just for the sake of explanation. So initially the normal force is radially outwards, finally the normal force is radially inwards. Some students might look at this and put in option C, but the actual answer is option D, because remember what is asked in the question: the force which the bead applies on the wire. If the wire applies this force on the bead, then the bead applies this force on the wire. So on the wire it's radially inwards initially and radially outwards finally. So the answer is option D. Let's look at the next question. We are given a meter bridge and it basically completes a Wheatstone bridge, and we want the unknown resistance. And the least count of the scale is 1 millimeter. So when it says that the distance x is 40.0 centimeters, it basically says 40.0 centimeters plus minus 1 millimeter, or 40 plus minus 0.1 centimeters. Right, now what will our equation be? R by 90 is equal to 40 plus minus 0.1 divided by, now the remaining thing would be 60, but this is 40 plus minus 0.1. If this is 40 plus 0.1, this would be 60 minus 0.1. And if this is 40 minus 0.1, this would be 60 plus 0.1. Right, so 60 is also plus minus 0.1. You have the same count in same error in this one. Right, from this we can see that this is equal to 40 times 1 plus 1 by 400 by 60 times 1 plus minus 1 by 400, 60 times 1 plus minus 1 by 600. Mm, 40 by 400 is 1 by 10 is 1, yeah. Right, so R is equal to 90 into this. So from that we can directly see R is equal to 40 by 60 is 2 by 3. 2 by 3 into 90 is just 60. Right, so R is equal to 60, but there's this whole thing here, and 60 is in two of the options. So we know that it's either A or C, but now we need to find the error as well. So here we have 1 plus minus 1 by 400, and here we have 1 plus minus 1 by 600. Now you know what we do in these situations. If the denominator is 1 plus 1 by 600, we multiply both the numerator by 1 minus 1 by 600, right? Or the opposite one. And then we just remove the second order things. So we'll take 1 and we'll take 1 by 400 or 1 by 600 multiplied by 1. But these two terms multiplied by each other, or the square of one term, we'll neglect because it will be very small. So multiply this by 1 minus plus 1 by 600 by 1 minus plus 1 by 600. Before that, I'll just try to tell you what we are doing right now here. What we are trying to do now. The actual answer is 60 into this, right? So R max is 60 times 1 plus 1 by 400 by 1 minus 1 by 600. That is the maximum value, right? The numerator will be maximum, the denominator will be minimum. And R min, let's say this is equal to R plus something or alpha. R min will be 60 times 1 minus 1 by 400 by 1 plus 1 by 600. This will be something like R minus beta or something. R minus, it will ultimately come out to be the same, R minus alpha. And then we'll write it as R plus minus alpha. So that's what we're trying to do when we try to do this calculation. So what this will give us is R is equal to 60, and the denominator will be 1 minus 1 by 600 whole squared. And we'll neglect the square of 1 by 600 in front of 1. So the denominator will just be 1. And the numerator will be 1. And then when you multiply plus 1 by 400 and you take that with minus 1 by 600, what you'll get is, sorry, if this is 1 plus 1 by 400, this will be 1 minus 1 by 600. So we'll multiply it by 1 plus 1 by 600. So either it's going to be both plus or both minus. So it's either 1 plus 1 by 400 plus 1 by 600, or it's 60 times 1 minus 1 by 400 minus 1 by 600. And we can already see what that plus minus thing is going to be. It's going to be 1 by 400 plus 1 by 600, or 3 by 1200 plus 2 by 1200, which will be 5 by 1200, and this will be multiplied by 60. So into 60, 6 by 120 is 20, which gives us 1 by 4, which gives us 0.25. So the answer is 60 plus minus 0.25. You could have actually just tried to get the values and do it as well. I just manipulated it a little bit so I would not have to calculate the values. But even then the answer would come out to be this thing. Basically the point is 40 plus minus 0.1. If you take 40.1, then this will be 59.9 and the answer will be 60 plus 0.25. If you take 40 minus 0.1, then this will be 60 plus 0.1 and the answer will be 60 minus 0.25. So the answer in this case is option C. Right. Let's look at problem 4 now. In problem 4, we are given 3 spheres uniformly distributed dielectric solid spheres. Dielectric solid spheres just means that they are not conductors, right? They are insulators, so the charge can be uniformly distributed within them. Radii r by 2r, r and r plus 2r. Magnitudes of field at a distance r. So this is easy enough. We'll just write the formulas for each of them. E1 will be, the charge on the first one is q, so kq by r squared. E2 will be k into, now the charge is 2q and the distance is still r, so 2kq by r squared. And for E3, we will only take the portion of the sphere that is enclosed within the sphere of region r. We will not take the whole of that. So k into q into, because now we won't take all of q, so the total radius is 2r, but we will only take r. And volume is proportional to r cube, so we are only taking 1/8 of the total charge. And this divided by r squared. So from this we can see that E2 is greater than E1, which is greater than E3. So the answer to this question is also option C. Let's move on to question 5 now. We are given a point source S placed at the bottom of a transparent block . This is a light source S at the bottom of a transparent block, which is kept inside a liquid. Right. So the block has a refractive index of 2.72 and this is, let's say, n, which we need to find out. We are given that the light emerging from the block to the liquid forms a circular bright spot of diameter 11.54. So rays will go like this, and we can assume that the liquid is rarer than the block. That's a reasonable assumption, and in that case there will be a radius, or an angle rather, I, an angle of incidence, beyond which there will be total internal reflection. So we just find out this angle, and what it's telling us is everything within this cone we'll be able to see. So this is a bright spot of diameter 11.4, which just means that this distance is the radius, which is 11.4 by 2, right? And this, if this angle is I, what is tan I? 11.54 by 2, this is the radius divided by this distance, the height, which is given to be 10 millimeters. Right. So tan I is equal to 11.54 by 20. Right. Now we are asked what is the refractive index of the liquid. Well, that's easy enough. If this I is the critical angle, that is the angle at which total internal reflection takes place, then 2.72 into sine I is equal to n into sine r, but sine r would be 1 because it comes out at 90 degrees. So this is basically our answer. Now we'll have to do a little bit of calculation. So it will be 2.72 multiplied by sine I. If tan I is this thing, then sine I will be 11.54 by root of 11.54 whole squared plus 20 squared, which will be 400. And if you solve this, it comes out to be equal to 1.36. So the answer to question number 5 is option C. Let's move on to question number 6. We have a sphere and there are parallel rays of a particular intensity I that are reaching the sphere. The sphere is a spherical black body, so along with this incident radiation, it is also absorbing radiation from the surrounding and it is emitting radiation. Right, and we assume that the energy exchange with surroundings is only through the radiation. What is the final steady state temperature of the black body? So if there was no radiation falling otherwise, then it would absorb as much as it radiates, and the answer would be 300 Kelvin, which is the temperature of the surroundings. But it is absorbing, so there is some extra radiation. So the radiation absorbed will be sigma A into T surrounding to the power 4 plus the radiation due to this I'll just write that in a minute, that will be equal to sigma A T to the power 4, and we want T, right? If there was nothing here, T would be equal to T surrounding, which is 300. Now what will this thing be? So some people might write this thing as I into pi r squared, I into 4 pi r squared. Area total is 4 pi r squared, but actually it will be I into pi r squared. And if you remember, you probably would have done this in physics class, you only take the perpendicular area, right, which is called the area of projection. Right, so this A will be 4 pi r squared, this A will be 4 pi r squared, and this will only be pi r squared. Right, so from that we can get sigma into 300 to the power 4 is equal to, we just divide by 4 everywhere, so this is I by 4, 912 by 4, sorry, plus 912 by 4 is equal to sigma T to the power 4. Right, and the value of sigma is given to be 5.7 into 10 to the power minus 8. So from that you can get T to the power 4 is equal to 300 to the power 4 plus 912 by 4 into 5.7 into 10 to the power minus 8. And to be very honest, you don't need to solve it too much because the options are quite far apart, 330, 660, 990 and 1550. And if you solve this, you'll see that the answer comes out to be T is equal to 330 Kelvin. But like I said, you won't need to solve it because you can easily look at this and see whether it's 330 or 630. It would be around 330 if you calculate this thing. Right. So the answer to this is option A. The important thing is in this question is these two are 4 pi r squared, but this is only pi r squared. Otherwise you would get the wrong answer. Let's do question 7. A metal surface is illuminated by light of two different wavelengths and the maximum speeds of photoelectrons are u1 and u2. u1 by u2 is given to be 2 by 1 or 2, right? U is the maximum speed. The maximum kinetic energy will be proportional to u squared. That means we can say K1 by K2, which is the maximum kinetic energy, is equal to 4. But we know that the kinetic energy maximum by photoelectric effect is equal to hc by lambda minus the work function. And you have the same matter in both cases. So the equation you get is hc, which is 1240, it's given. So 1240 by 248 minus phi divided by 1240 by 310 minus phi is equal to 4. Right, just substitute k from these two equations. This comes out to be 5 and this comes out to be 4. So which means 5 minus phi is equal to 4 times 4 minus phi, which means 5 minus phi is equal to 16 minus 4 phi, which means 3 phi is equal to 11, or phi is equal to 11 by 3, which is approximately 3.7. So the answer to this question is 3.7 electron volt, or option A. Question 8. Lambda Cu is the wavelength of the K alpha X-ray line of copper, and lambda MO is the K alpha line of molybdenum. We already know the relation between the frequency for the K alpha line, root mu, is equal to A times Z minus B, and you often take B is equal to 1 unless something else is given, so it's A into Z minus 1. That is root mu, and we already know that lambda mu is a constant, which is C. So in this case, mu is inversely proportional to lambda. That means lambda Cu by lambda Mo is equal to mu Mo by mu Cu, right? Because they're inversely proportional, which is equal to mu Mo by mu Cu is approximately equal to A times what is Z of molybdenum? That is 42. So 42 minus 1 is 41, divided by A times 29 minus 1 is 28. Right. And this would be squared, because root mu is equal to A into Z minus 1. So the answer is 41 by 28 whole squared. And if you approximately try to calculate the value of this, it will come out to be 2.14. So the answer to this problem is B. This was a simple problem, just you had to use Moseley's law. And since B wasn't given, take B is equal to 1, but we weren't given anything else and we won't be able to find the ratio otherwise, B was approximately equal to 1. Question 9. We are given a planet R. A planet has a radius r, which is x by 10, where x is the radius of the earth, re. It's generally more commonly denoted by re, and the same mass density. Scientists dig a well of depth r by 5 in it. So this is the planet of radius r. You dig a well of depth r by 5 and lower a wire of the same length and of linear mass density 10 to the power 3 into it. So you basically replace this area by a wire. And if the wire is not touching anything, the force applied at the top of the wire by the person holding it is, so we need to find out the force applied on this wire. So somebody will be holding it at the top by a force F, because that will need to compensate for the gravitational attraction of this wire, right? So this F will be equal to the gravitational force felt by this wire, which we can find out quite easily. We can just assume a spherical shell of radius small r and thickness dr, and we can calculate the force on this material due to this shell. So if we consider this element, let's call it dr, then the force on this element will be, or we just call it fr, it will be the mass of this element, that is dm, whatever the mass is, into rho, multiplied by the gravity at this point. Now the gravity at this point will consist of everything between this region, right? Not the sphere part that is outside of it, but everything that is inside it. I'll try to draw a better figure because I think that will be important. So this is R by 5. This is dr, and this whole is R. Right, so everything within this region will contribute. So this is the mass into gm by r squared. G into the mass of this part. The mass of this part will be the total mass of this planet into r cube by r cube. And this will be divided by small r squared. Right, so this is the force, and we need to put in dm as well. Dm is equal to, hang on, sorry, this should have been dm, I made a mistake, this should have been dm, and dm we will replace by rho dr. Rho is the linear mass density, dr is the length, right? And we just integrate it, but the limit goes from 4r by 5 to r, from this point to this point. This will be equal to the total F. How much is this equal to? Gm rho by r cube, this we take out, integral of r dr 4r by 5 to r, which is r square by 2. So 2, and you have, this would be r squared. That means r squared 1 minus 4 by 5 whole squared, 16 by 25, which is 9 by 25. So we get F is equal to 9 gm rho, and this is r square, so only r is left, 50r. So this is the force, right? We need the value of this force. However, we do not know what m and r are, right? But we do know one thing: this radius is equal to x by 10, where r is the radius of the earth. And we know the gravitational force at the earth, or small g, which is 10 meter per second squared. So we can use that. So we know 10 is equal to g times the mass of the earth by radius of the earth whole squared. So the radius of the earth is x squared. What is the mass of the earth? The mass of the earth will be, now I'll try to use another term, rho earth here, right? Because this rho is the mass density of this wire. I should have used lambda here. I'll do that actually. I'll use lambda here and make this rho, because rho is generally mass density and lambda is the linear mass density, which we should have used. So x square is x is the radius of the earth, so x square is that square, rho into x cube, right, into 4 by 3 pi. This we know is 10. From that we can get the result. This is just x, so g, capital G rho x is equal to 30 by 4 pi. Right, so this is one result we get. Now this, again we'll write m and r in terms of x and rho. So this is 9g lambda by 50. R I can write as x by 10. So x by 10, that means it's 5x. And here is the mass. The mass will be rho times r by 10 whole cube. Right, sorry, x by 10 whole cube, right, r cube. So 4 by 3 pi into r cube, which is x cube by 10. Right, so how much does this come out to be? And we'll just input the value right here. G rho x is 30 by 4 pi. So G rho, and this is x squared because 1 cancels. So we'll just leave 1x, and the G rho x that is left is 30 by 4 pi. And this cancels a lot of stuff. 3 by 4 pi cancels with this and leaves us with a 10. Right, and that 10 cancels with this 10. And what we are left with is 9 lambda by 5. I might be mistaking a 10 here. Let me just check. So, yes, m is written to be 4 by 3 pi x cube by 10. No, it should be x cube by 10 cube. Yes. So this was 10 cube. 110 is cancelled. We still have 100 left. So 9 lambda by 500 is the force. Into x, right? There's still an x left. So 9 lambda by 500 x is the force. That comes out to be 9 by 500 into lambda is given to us to be 10 to the power minus 3 into the radius is given to be 6 into 10 to the power 6. So this cancels with this, gives 10 to the power 3. This cancels with these two, gives 10, which cancels with this, gives 2. So we have 12 into 9. 12 into 9 is 108 Newton. So the answer is 108 Newton, which is option B. Right, I won't suggest, I know this has been a little untidy in the calculation, but you do it yourself. I've told you the exact concept, right? The concept should be what is important. And ultimately, if you do it correctly, then you will get the answer. The force is 108 newtons. We got this value. That was the conceptual part. And then what they did was, instead of giving us the radius and mass of this planet, they gave us the radius of this planet in terms of the radius of the Earth, telling us that they are basically made of the same material, and knowing that for the Earth, gm by r squared is equal to 10. And they gave r. So basically what they did was, they gave us r, and they know when we know gm by r squared. So they said you can find out m, and then this density you'll know is the same as the density of that planet, so you can find out the other stuff as well. So sort of a lengthy question. Chances are somebody might make a mistake somewhere, but not a very difficult one conceptually. Question 10. We have a glass capillary tube in the shape of a truncated cone. So it's something like this. Right, this is the glass capillary. Instead of the standard test tube, it's like this, and this, when extended, makes an angle alpha. Its apex angle is alpha, and it is put inside water, and you have some water rising, and the contact angle is theta. Now it would be the standard thing, you know, except the contact angle now is this angle, right, which is theta. Right, normally the wall was vertical, so the contact angle was the same as the angle with the vertical. That's not true in this case, right? And this angle, what is this angle? The rest of it with the vertical, this is alpha by 2, because this would be alpha by 2, right? Alternate interior angles. So the equation you'll get is S into the radius is B. So S into 2 pi B, that would be the force acting. But that force would be acting along this direction. And if the wall was vertical, you would do that into cos theta. But that's the difference in this question. Now you need to do this into cos of theta plus alpha by 2. Because we want the net vertical component of this. That is equal to the net gravitational force, which is pi b square h, and what else is given in the question? Rho g. Because we are given this is B and this height is H, and we can almost assume it's actually, I've drawn the figure sort of wrongly. It's generally, the figure would be something like this, right? It rises up, and then at the edge there's a contact angle. It won't generally be a sphere like this, right? It'll be like this. So the volume will be pi b square h rho g, and from that you can get you need the value of H. That will be B cancels with this, so 2s cos of alpha plus cos of theta plus alpha by 2 by B rho g, which is option D. So the answer to this question is option D. Let's move on to the comprehension type questions now, starting with question 11. So you are given a container which is divided into two compartments, and there is a piston on top of the upper compartment. And the upper part has 2 moles of diatomic gas at 400 Kelvin, and the lower part has 2 moles of monoatomic gas at 700 Kelvin. and the specific heat capacities are given, molar heat capacities rather, and they are what you would expect. In question 11, it's given that this partition is rigid and what is the final temperature of the gases. So as this particular compartment is giving away heat, it will follow an isochoric process because this wall is rigid, so the volume will be constant, which means we will use CV here. But as the upper compartment absorbs the heat, its pressure will be constant, not volume, because this piston is free to move and the property of a piston is it keeps the pressure constant. So here we will use CP. And if you assume that the final equilibrium temperature is T, then obviously the lower part will give heat. So we will get 2 into CV for the lower part, which is 3 by 2R, into 700 minus T. This will be equal to the heat absorbed by the upper part, which is 2 into, and now we'll use CP for the upper part, which is 7 by 2 R into T minus 400. 2 and R cancel, so what we get is 2100 minus 3T is equal to 7T minus 2800, or 10T is equal to 4900, which means T is equal to 490 Kelvin, which means the answer is option D, 490 Kelvin. Now for the 11th question, I'll rub this. In the 12th question, the difference is that now the partitions are free to move without any friction, right? So in this case, both of them will follow an isobaric process. The upper part will follow an isobaric process, and because its pressure will be constant, the lower part's pressure will be adjusted such that it also follows an isobaric process. So the equation will now be 2 into CP for both of them, 5 by 2R into 700 minus T is equal to 2 into 7 by 2R into T minus 400, which gives me 3500 minus 5T is equal to 7T minus 2800, which gives me 12T is equal to 6300, or T is equal to 6300 by 12, which is 525 Kelvin. But we are not asked the temperature, we are asked the total work done by the gases till the time they achieve equilibrium, right? So that's easy enough. We need to find out, because these are isobaric processes, for both of them the work done will be P delta V each, right? P is constant for both of them, and delta V then will be the change in volume. So for both of them we can use, in an isobaric process, V1 by T1 is equal to V2 by T2. And let's assume initially the total volume was V, right? So initially the total pressure obviously was the same because it's free to move. So that means initially the volume was divided into the ratio, in the ratio of temperature. This is 400 and this is 700. So this is obviously 4V by 11 and this is 7V by 11, right? I hope nobody is confused on how I got this. This is 4x, this is 7x, their sum will be the total volume V, right? So when we apply this to both of them, V1 for the upper one will be 4V by 11. So we get 4V by 11 divided by initial temperature 400 is equal to V final divided by the final temperature 525, which gives me, this cancels with this, and 100. So V by 1100 is VF by 525. So VF is 525 by 1100 V. Okay. Similarly, 7V by 11 by 700 is equal to VF for the second one. So let's say this was 400. So this is V upper final and this is V lower final divided by 525. So we get the same thing final. In this case, V lower final is equal to 525V by 1100. right? They don't need to add up to V because the total volume does not need to be constant. So these are the two final cases, right? Let's assume the pressure throughout is P. We'll calculate its value at the end. So the work done by the first one, by the gas, upper gas, will be P delta V. So P into 525 by 1100 minus 11 by 4, minus 4 by 11. Minus 4 by 11, which is 400 by 1100. So this is the upper one, sorry. So the work done by the upper one is equal to P, and there's also obviously a V here. So it is PV times 125 by 1100. Similarly, the work done by the lower gas will be PV times. Now in this case the volume has increased, but in this case this is less than 7 by 100. 7 by 11 V, which is 700 by 1100, so the volume has decreased, so the work done will be negative, and it will be PV times 700 minus 525, that is 175 by 1100. So the total final work done is the sum of this, that will be PV times minus 1 times minus 50 by 1100. 50 by 1100 is 5 by 110 is 1 by 22. So minus PV by 22, this is the work done. Now we can just calculate the value of PV by using any initial condition. Initially for the upper part, 2N into R into 400 is equal to P into 4V by 11. 4 and 4 cancel. So what we get is PV is equal to 1100 into 2 is 2200 R. So minus PV by 22 is equal to minus 100 R. So the answer to this question, question 12, is minus 100 R. This is question 12, by the way. Question 11 was the previous one, in which we just calculated the temperature, which came out to be 490. In this case we needed to calculate the work done, which is minus 100 R. So the answer to this question is option D. Let's move on to the next comprehension type, question 13. So we are given a piston which has two areas of cross section. A spray gun with a piston which has two areas of cross section of radii 20 mm and 1 mm. The piston is pushed at a speed of 5 mm per second. So this is a simple question based on the equation of continuity. A1 V1 is equal to A2 V2, because the amount of water going in is equal to the amount of water coming out, which means pi into 20 mm whole squared into 5 mm per second is equal to pi into 1 mm whole square into V. So what we get, V is equal to 400 into 5, that is 2000 millimeters per second, or which is equal to 2 meters per second. So the answer to question 13 will be C, 2 meters per second. Direct application of the equation of continuity. Right. Let's do question 14, in which we'll have to use Graham's law of diffusion, which tells us that the rate of diffusion of one thing by another thing, here of the rate of the diffusion of the liquid by that of the air, is equal to the root of, is proportional to the root of rho of air by rho of the liquid. Right. And we are asked that this speed or the volume per unit time at which the liquid is sprayed is proportional to, so this is RL by RA. The total thing will actually be RL by RL plus RA. Right, the rate of liquid by the total rate of spraying of both liquid and gas. So that actually does come out to be root of rho A by rho A plus rho L. But the thing is, because L is a liquid and A is a gas, rho A can often be neglected in front of rho L, so we can use the original answer of this approximation anyway. So the answer will still be rho A by rho L, but just to inform you, this is the ratio of liquid to air, but we wanted the rate in which is proportional to the total rate. Right, the rate volume per unit time at which the liquid is sprayed will be proportional to rho A by rho L, Graham's law of diffusion. So the answer to this question will be A. Let's move on to question 15 and 16, where we are given there are two wires, 1 and 2, and there's a loop of radius a, and these two distances are d each. This is PQ, this is RS, and we are given a particular direction of current here. So the figure shows a circular loop with two parallel lines. The distance from the center is I. The current in the loop is in the counterclockwise direction. So question 15 says when D is approximately equal to A. This basically means when D is equal to A, except these are not touching. When they touch, then continuity might not be violated. Some current going here might go into this wire or something. So just for the sake of that, they have said that it's not touching, but for all practical purposes, we'll just take D is equal to A. Right. It is found that the net magnetic field on the axis of the loop is 0 at a height h above the loop. Right. So we already know what the magnification for a loop is. The formula for that is, if we look at it from this direction, if you look at it the side view, then this is the loop we'll see, which has a radius a, and at a height h from this point, the magnetic field due to this loop will be given by mu naught I a squared by 2 times a squared plus h squared to the power 3 by 2. Right, this is a standard result, I won't derive it, and it depends on what the direction of the loop is. If it is such that it's towards the fingers curl towards the right hand like this, then it will go towards this side. Right, it's along the axis, that is the important thing. So mu naught I a square by a square plus h square to the power 3 by 2, I'll just write it more clearly, is the magnetic field due to the loop. This is the B loop. What is the magnetic field due to the wires? Now this question I really like, because one thing we need to do in this is to look at perspectives a lot, and this is the way this would look, plus the two wires here if we look at it from this side. What about if we started looking at it from the top? That we need to do in order to look at the magnetic field due to the wires. So from the top, this would just be a wire, right, and this would be the other wire. This is, let's say, point S, and this is point Q, which we are looking at. Here you will have the center along this line, and what you'll have is a point H from here. This is A, this is H. We need the magnetic field here, right, and here. So if both of them have a magnetic field in the same direction, let's say going into the plane, then the magnetic field due to this one will be like this, perpendicular to the line due to S, and due to Q, if it's also going into the plane, will be like this, and the sum of them will be like this. But we don't want it to be in this direction, we want it to be in the horizontal direction. That means Q and S will have to have currents in the opposite direction, right? So let's say Q has current going into the plane, so this is the direction of magnetic field for Q, and S has the current coming out of the plane, so the direction for magnetic field from S will be like this, and they will give the resultant here, right? I'll just try to draw this one again, because A seems to be equal to H, which doesn't need to be true, so we need to draw a figure with a better perspective. So this is S, this is Q. They are not joined, I'm just joining them for the sake of manipulation now, right? And let's say this is H. So if this has a current going into the plane, this has a current coming out of the plane, this will have a magnetic field perpendicular to this line like this, Q, and S will have a magnetic field perpendicular to this line like this, and they will have the resultant like this, which needs to be equal to the B of the loop, right? So this is A, this is H, let's call this angle theta, this is 90 minus theta. So B due to the first one, BS, is equal to mu naught I by 2 pi S, that is 2 pi A square plus H square to the power 3 by 2. and we take cos of 90 minus theta for this, which is sine theta, to go in this direction, and we double it because this is the same contribution by q, so we double it, and then we can put the value of sine theta. Sine theta is a by root of a square plus h square, right? So this is just root of 1 by 2, right? And now here sine theta can be written as a by root of a square plus h square, so you just get a by a square plus h square, right? Now these two things have to be equal, right? So we can just equate them. Mu naught I and mu naught I will cancel, and this 2 will, let's say, cancel with this 2, and what we are left with is we need to find the relation between h and a, right? So what we are left with is mu naught I, a has been cancelled, just a is left, so a by a square plus h square to the power 3 by 2 is equal to 2 by pi root of a square plus h square, pi into a square plus h square, no root, sorry, right? So a square plus h square we can cancel, this will be root of this, means this to the power 1 by 2 is 2 by pi. So we can just say that pi a, or pi squared a squared, is equal to 4a square plus 4h squared, or h is equal to a times root of, so 4h square will be pi square minus 4, so pi square minus 4 by 4, and if you try to calculate this value, it will come out to be pi square is approximately 10, so 10 minus 4 is 6, 6 by 4 is 3 by 2, root of 1.5 is approximately equal to root 2, so the answer 1.2 whole square is 1.44, so it's approximately 1.2a. So 1.2a, and they are going in the opposite direction, so it's either C or D, and the direction has to be PQ and SR, right? It can't be PQ and RS, it has to be PQ and SR, so the answer is option C. So this is a good question, one of the more difficult questions, not requiring just knowledge but actually a level of intelligence to be able to calculate these terms directly as well. I like this question. Let's move on to question number 16, which is based on the same concept, based on the same comprehension. So in 16 we have the approximation D is much greater than A, and the loop is rotated about its diameter parallel to 30 degrees. If the current in wires are in opposite directions, the torque at its new position will be. So this is a much simpler problem, because in this we are only talking about between the wires, not at inside or outside the plane. So if they are in the opposite direction, the magnetic field due to them will be 2 times mu naught I by 2 pi d. Right, they'll be in opposite direction, so the magnetic field will add because of them. Right. Now this is the magnetic field. We know that torque is equal to mu cross B. Mu is, now we don't have to worry about anything else because the loop is very small now. So for the loop, the mu will be pi a squared times I into B, that is mu naught I by pi d, into sine theta. And since it's rotated by 30 degrees, this will be sine 30. So which gives me pi and pi cancel, a squared mu naught a squared I squared by d, and there's a 2 here because of sine 30. So that gives me the answer as option B. So the answer to question 16 is B. Let's move on to match the following, starting with question 17. So we are given 4 charges, Q1, Q2, Q3 and Q4, and there's a point Q here, and for different values of the signs of the charges, we need to find out the direction of the force on a particle of positive charge Q. So which basically means the direction of electric field, because this charge is positive. We know the electric field due to all 4 of them will be radial. Whether it will be radially outward or inward, really depends on what sign those charges possess. Right, this is A, this is 2A, minus 2A, minus A. So in option P, all four charges are positive. So all four of them will have radially outward electric fields. So the sum will be in this direction by symmetry, which is the positive y direction. So P will be option 3. In Q, we have Q1 and Q2 are positive, so they'll give it in this direction, but Q3 and Q4 are negative. So they'll actually have electric field in this direction, and by symmetry, the sum will be in this direction, or the positive x direction, which will be option 1. Let's look at option R now. I'll remove the arrows for the sake of clarity. So for option R we have, hang on. Yeah, so this is how they are, they're all symmetric. Option R we have Q1 and Q4 are positive. Right, so Q4 gives us like this and Q1 gives us like this. And Q2 and Q3 are negative, so this is in this direction, this is in this direction. So we can already tell that it will be in the y direction by symmetry, but it will be in the negative y direction because Q2 and Q3 are closer, so their contribution will be greater than Q1 and Q2. The magnitude of these two forces will be greater than the magnitude of these two forces. So it will be in the minus y direction, which is option 4. S has to be option 2, but let's check anyway. Q1 and Q3 are positive, so this one and this one. And then Q4 and Q2 are negative, so Q2 gives me this one and Q4 gives me this one. Again, the sum is in the x direction, and Q2 and Q3 determine what the direction will be because they are closer, and both of them give a magnetic field towards the left, so it will be towards the left, which means it's in the minus x direction, which is option 2. So 3, 1, 4, 2, which gives me the answer as option A. So the answer to this problem is option A. Let's look at question 18. So we are given 4 lenses . So these are 4 lenses and we want to find out the focal lengths of these. So it's easy. All we really need to do is what is the formula? The formula is 1 by f is equal to mu minus 1 times 1 by r1 minus 1 by r2. In this case, 1 by f will be mu is 1.5. So 3 by 2 minus 1 is 1 by 2 times 1 by r1 minus 1 by r2. Now the whole key in this question is to put up the proper signs, and once you put up the proper signs, the answer will come. Find the focal length for each of the 2 lenses, then just use 1 by f is equal to 1 by f1 plus 1 by f2. Right. So let's do this for each of them individually. Let's do it for P. In P, just 1 by f will be 1 by 2 times, now this is 1 and this is 2, right? So 1 by r1 minus 1 by r2. r1 is positive, r2 is negative. Both of them have a magnitude r, right? So 1 by r minus 1 by r. So half of 2 by r. So which means 1 by f is equal to 1 by r, which means f is equal to r, and they both have the same thing, right? So 1 by r plus 1 by r, that is 2 by r, which means for P the answer is r by 2. Right. Now let's look at Q. In Q, we have 1 by f is equal to 1 by 2 times. Now 1 has a radius of infinity and 2 has a radius of minus r. So 1 by infinity minus 1 by r. Right, this is what it gives me. The whole question here depends on the signs. You have to use the right signs. So this gives me 1 by f is equal to 1 by 2r. Right. Now 1 by 2r is for the first one. So 1 by F1 is 1 by 2r. What is it for the second one? 1 by F2 is equal to half, which is mu minus 1 into, now this is 1 by r and this is infinity. The first one is positive. Every radius towards the right is positive. 1 by r minus 1 by infinity. So 1 by F2 is also 1 by 2r. Their sum will be 1 by r. So for this, the answer is r. So for Q, the answer is r. What is it for r? 1 by F1 is equal to half of, now this is infinity, this is positive r. So 1 by infinity minus 1 by r, which means 1 by F1 is equal to minus 1 by 2r. And if you take the other one, this is negative and this is infinity. So you will get minus 1 by r minus 1 by infinity, again minus 1 by 2r for the second one as well. You add them up, you will get minus 1 by r. So for this one, the answer will be minus r, not r. Right, the negative of that. And in this one, we've already seen f is equal to r for the first one. So 1 by f, this is for s, is equal to 1 by r plus, for the second one, we just saw what it is right now, minus 1 by 2r. So minus 1 by 2r. So 2 by 2r minus 1 by 2r is 1 by 2r, means this is 2r. Which means this is option 1, this is option 4, this is 3, and this is, hang on, 2, 4, 3 and 1. 2, 4, 3, 1 is the answer, which gives me option B. So the answer to this question is option B. Quite a simple question, but you have to make sure you use the right signs. Every radius, every surface like this has a radius of curvature positive because it's towards the right. Every surface like this has a radius of curvature negative because it's towards the left. Let's move on to question 19. So we are given an inclined plane of inclination theta and two objects M1 and M2 where the friction only acts on M2, it does not act on M1. Yeah, the coefficient between M2 and the plane is 0 and between M2 and the plane is 0.3 and between M1 and the plane is 0 and M1 is equal to 1, M2 is equal to 2. So first of all, let's see when there will just be slipping. When the slipping will just begin, the total frictional force on this combined system, which will be mu mg cos theta, mu m2g cos theta, has to be equal to the total gravitational force, which is m1 plus m2 g sin theta, which means 0.3 into 2 cos theta is equal to 3 sin theta, which means tan theta is equal to 0.2, which means theta is equal to 11.5 degrees. That means 11.5 degrees is when slipping starts. So we have P, Q, R and S options. For P and Q there is no slipping because it's less than 11.5 degrees. For R and S there will be slipping because it's more than 11.5 degrees. And the friction is in list 2. So when it is slipping, that is P and Q, the friction will be equal, when it is not slipping, which is P and Q, the friction will be equal to whatever is needed, that is M1 plus M2 g sin theta, which is option 2. So both of these have an option 2. For R and S, when there is slipping, friction will just be mu n, even if that can't cover M1 plus M2 g sin theta. So friction will be mu M2 g cos theta, which is option 3. So P and Q get option 2, R and S get option 3, which means the answer is D. Right? Let's do the final question of this physics paper. This has to do with the velocity of efflux. This is a height capital H, and then here you have a hole in a bucket of water of height small h, and water is coming out and it goes like this. So we know what the velocity of efflux is. V is root of 2gh, right? And how much time will it take to fall here? The vertical velocity initially is 0, so h is equal to half gt squared, which means t is equal to root of 2 capital H by g. And this is the speed. So the horizontal distance covered will be Vt, which is root 2gh into root 2 capital H by g. And g and g cancel, and we get root of 4h capital H. Right. And the questions are given, lift is accelerating vertically up, accelerating vertically down. What is this value of d? It is root of 4hh, and the values of capital H and small h are given as, no, wait a second, the question is, when the lift is at rest, this is equal to d, 1.2. And then you keep it in motion, which means the gravity is changing. But we see that the final answer, Vt or d, does not depend on gravity. So it will be 1.2 in every case, except in the last case where it is falling freely. When it is falling freely, this won't even come out because this speed will be 0. Right? And you can't say that this is 0 and this speed is 0, and so this whole term will cancel g and it will be this term, because there just won't be any water coming out, so there won't be any d. Right? So no water leaks out in case S, which is 4, but in all the other three we'll have 1, which is d will be 1.2, because it does not depend on the gravity. As the gravity decreases, the speed decreases, but this distance increases. Right, because the time taken to fall increases. Sorry, the distance remains constant because time taken to fall increases. So the answer in this case will be 1, 1, 1 and 4, which is option C. This completes the physics portion of the 2014 JEE Advanced Paper 2. Thank you.